How are you, my dear student? In the previous lecture we explained what is the meaning of daily compounding and what is the meaning of yearly or nominal compounding, monthly compounding, semi-annually, quarterly, monthly compounding. But today we will explain what is the meaning of daily compounding. This is the last thing in compounding rates, nominal or yearly, semi-annually, annually, quarterly, monthly, and the last may be daily compounding. What is the meaning of daily compounding? The Board of Governors of the Federal Reserve System establishes the maximum nominal rates that member banks may pay on time and saving deposits. The Federal Deposits Insurance Corporation has similar authority with respect to deposits in insured non-member banks, and the Federal Home Loan Bank Board establishes the maximum rates paid by federally insured savings and loan associations. Since interest rates are the price of credit, you must note that interest rates are the price of the credit. This is maybe in your MCQ exam. Interest rate is the price of credit. This federal freeze on rates is one of our few peacetime examples of price controls. The greatest impact is on small savers. Affluent investors who have more alternatives for investing money can find higher rates in other investments such as bonds or certificates of deposit, as we explained in chapter 2, certificate of deposits. Since there are no restrictions on the frequency of compounding, banks and savings and loan associations try to attract depositors by loanable funds is great. With a fixed nominal rate, more frequent compounding results in depositors earning more interest. For a given nominal rate J, as we explained in the previous lectures, J, the amount of one factor for a 360-day year is computed from the expression 1 plus J over 360 to the power I, where to the power T, where T is the time in days. The amount of one factor for a 365-day year is computed using 1 plus J over 365 to the power T. Until now, there is no any problem about daily compounding. This is only a brief introduction, a small introduction about what is the meaning of daily compound. By another meaning, this is only reading this slide 3.9 daily compounding, only reading for you to understand what is the meaning by daily compounding, what is the difference between yearly, monthly, semi-annually, quarterly and daily compounding, so that we must understand very closely this slide, only reading to understand what is the meaning of daily compounding. Illustrations for daily compounding. But the more important, in this slide you must note that interest rates are the price of credit, and we will explain how we can solve a daily compound, problem to find the rate. in this lecture we will know how we can compute, how we can solve the problem related to daily compounding. Now, we will explain our example to understand what is the meaning of daily compounding. Compute the amount of one factor for 5%. 5%. 5% converted daily for 1, 2, and 3 days for 360 and 365 days. This is a very important example to understand what is the meaning of daily compounding. Again, compute the amount of one factor for 5% converted daily for 1, 2, and 3 days for 360 and 365 day years. Solution. For a 360 day year, we find that 1 plus j over 360 equal 1 plus 0.05 5% over 360. And you can find the result. We now raise this factor to a power equal to the number of days. Number of days 1, number of days 2, number of days 3. This is the amount of one factor. The amount of one factor, you must note that. You must understand this factor very closely. The amount of one factor, so that this amount of one factor called 1 plus j over 360. This is for 360 day year. And the power 1 day, 2 day, and 3 day as stated in the head of the problem. For 365 day year, 1 plus j over 365. This is the amount of one factor. The amount of one factor for 365 day 1 plus j over 365 equal 1 plus 0.05 over 365 and the power 1, 2, and 3. Some institutions will pay interest based on bankers' rule, so that I want from every student, number 1, to know what is the meaning of one amount factor or factor of one amount in the compound interest. 1 plus j to the power over 365 or over 360 to the power t. And in banker's rule, the amount of one factor, banker's rule, so that at the end of year t equals 365 over 360. And the amount of factor is 1 plus j over 360 to the power 365. This procedure will produce even more interest for the investor. For example, the amount at 8% compounded daily for 1 year using banker's rule is S equal 10,000 multiplied by 1 plus 8% over 360 to the power 365. So that's the amount $10,844.82. If the same investment had been made using exact interest and exact time, the value would be 10,000, this is the capital, multiplied by 1 plus 8% over 365 to the power 365 days equal 10,000 multiplied by 1.08327775. The result equal 10,832.78. Banker's rule So that banker's rule, this is the result, this is the conclusion. Banker's rule produces 12.04 dollars in additional interest at the same rate. Now, 3.10 effective interest rates. This is very important part in compound interest. You must understand very closely. To put different rates and frequencies of conversions on a comparable basis, we determine the effective rate R. The effective rate, as we stated in the previous lecture about interest rate R, about bank discount small d, this is R in compound interest effective rate. The effective rate is the rate converted annually that will produce the same amount of interest per year as the nominal rate J converted M times per year. If the nominal rate is 6% converted annually, the effective will be also 6%. But if the nominal rate is 6% converted semi-annually, the amount of $1 at the end of 1 year will be 1.03 to the power 2. This calculation is simply the accumulation factor for a rate period of 3% and 2 period. The interest of $1 for 1 year is then $1.0609 minus 1. The result 0.0609. This result is equivalent to an annual rate of 6.09%. Thus, 6.09% converted annually would result in the same amount. Interest at 6% converted semi-annually, the computations used to get the effective rate of 6.09% in this case can be summarized as follows. 1.0609 equal 1.03 to the power 2. We will make our investigation, our mathematical induction الاستنتاج الرياضي to obtain an equation to find the effective rate in general. The effective rate must be found by a mathematical steps. We assume that the effective rate produces the same amount S from the given principal P in 1 year as the compound interest. We then have S equal P multiplied by 1 plus RT equal B 1 plus R and S equal B multiplied by 1 plus I to the power M, setting the value of S equal B multiplied by 1 plus R equal B multiplied by 1 plus I to the power M. Divide both sides by B1 plus R equal 1 plus I to the power M. R equal 1 plus I to the power M minus 1. This is in your book. And we want extract R. This is R. We found R equal 1 plus I to the power M minus 1. Very important relation. You must know this relation very closely because this relation may be in your MCQ. Notice that the effective rate is determined only by the nominal rate and the frequency of compounding. The effective rate does not depend on the amount of the principal, as M, the frequency of conversion. This is conversion period. Conversion period you can found it only in compound interest. There is no any conversion period in simple interest. There is no any conversion period in bank discount. But conversion period you must found in compound interest. So that as M, the frequency of conversion is increased, the effective rate corresponding to a given nominal rate gets larger. However, the increase becomes less rapid with large values of m. This is an illustrative example. Find the effective rate of interest equivalent to 8% converted semi-annually. Solution: the rate per period I equal 4% because it's semi-annually must be divided by 4, and m equal to conversion period. In getting the effective rate, it is usually sufficiently accurate to take the amount of one factor from table 2 to 4 decimal places. Substituting in formula 10, we have 1 r equal 1 plus 4% to the power 2 minus 1. This is as we find in the previous slide. You can find r equal 8.16%. Thus 8.16% computed annually will produce the same amount of interest at 8% computed semi-annually. This is the final of our lecture today, and I want from every student to take notes about this lecture and all lectures, and registered all notes and all questions in separated paper to understand what the meaning of this lecture and previous lectures. Thank you for everybody. See you in the next lecture.